Domain and range of continuous functions notes. Really quickly, yesterday we did discrete functions, which look kind of like scatter plots. Today we're talking about continuous functions. So do you notice all the functions on this paper have lines or they're connected all together? They're not just points. That's what we mean when we say continuous functions. When we have continuous functions, we have to use inequalities to express our domain and our range. You probably already know these, but let's run through them very quickly. When we have this sign here on the left, this is called a less than sign. And when it's pointing the other direction, we say this is a more than sign. All right, these two, we use open circles. Okay, you're going to understand that more in a second. So we use open circles. On the next side, you guys can see we have those lines underneath our inequality symbols. This means that we use a closed circle. So this here is a less than or equal to. This is a greater than or equal to. And since both of these inequalities have those lines underneath, we use closed circles. It's a matter of inclusion. Do we want to include the point we're stopping at, or do we not want to include the point we're stopping at? Right? It's kind of like the whole greater than or equal to, the or equal to part of this. Okay? Let's go ahead and let's get started. We're going to look at example number 1. In example number 1, you are supposed to find the domain and the range of this line. Now remember, when I say domain, you say x. Those are our x values. What I would really encourage you guys to do to help your brain out so much is to draw a box around your function. You always want to draw a rectangle, like don't do any other shape here. Here's what I mean. I'm going to go ahead. Here's where I start, and on the right, I go all the way here, and then frame my graph here with this rectangle. Here we go, over there on the side, and then again, all the way back down here. So these are the only places on the graph that we have points. So my x values, if I'm looking from left to right, my x values are from left to right, only encompass these x values. Every single point on my line, the x values will be between here, which is 0, and here, which is positive 4. So x is between 0 and 4. All my x's on my line are between 0 and 4. Now, did you notice that all the way here at this leftmost point, I have a closed circle? That means I need an or equal to line on my inequality. Over here on the right, my furthest point to the right is up here. I need that line underneath because it's a closed circle. And that is how we express the domain. This literally means all the x's are between 0 and 4, or possibly 0 and 4 themselves. Let's go ahead and let's now look at our y values, okay? Our range values. Choose a different color here. Okay, so all my y values, my range values, right? They go, this is the lowest point and up here is the highest point, right? If we look here at our axis, the lowest point is down here, the highest point is way up here. So all my y values go from the lowest point, -4, to the highest point, +4, right? All the y values are between there. And again, because both of our circles at the ends were closed, we've got less than or equal to signs. That or equal to line on the bottom is crucial, okay? Some things to notice. Domain always has an x in the middle, right? Range always has a y in the middle. It's very important. If you're taking a test and you're asked a question about domain and you see y as an answer choice, cross it off. It's not right. Domain is x. Same thing with y, okay? Let's try another example. Here we go. We're going to look at the next problem, example number 2. So again, I highly encourage y'all, draw a rectangle to kind of frame your graph, and it's really helpful. So I'm going to do mine here. All my points are between, oops, that's too short. All my points go between here. Okay? So all my possible x values, remember x goes left to right, and they go from here all the way to here. All my points on my line, the x coordinate will be somewhere between, what's that, -4? Or possibly all the way to +4. All my x's are between there. Now because my endpoints are open circles, I do not need the or equal to lines on my inequalities. Okay, don't put them there. These correspond to the open circles. So what we just wrote was all the x's for this line are between -4 and +4. Let's try the y's. Okay, let's try the y's. Right? Y's are my domain. So my lowest point is over here. My highest point is here. So all the y's are between what? The lowest point was down here when y is -1. The highest y was up here when y is +1. All the y's are between -1 and 1. So we're going to say less than and less than, right? We don't need lines under here because my circles on my graph were open. All right. Again, what this says is all the y's are between -1 and 1 for this graph. Okay, let's move on to example 3. I'm going to start going a little bit faster here. Now you might notice here I've got an open circle and I've got a closed circle, and we're going to address that here in just a second. Okay, so let's go ahead and let's get started with my domain. Oops, you know what? Let's get started with my rectangle to draw this thing. All my points are between, or somewhere in this box, kind of, right? All right, so let's start with my x's, my domain. Well, from left to right, I go from here to here, right? Those are the furthest left, the furthest right points I have. So all my possible x values are going from here at -4 and here to 2. Now -4 all the way to +2. All my x's are between here. Now did y'all notice that when x is 2, I have an open circle? So for this sign, I don't want an or equal to line under it. But then when x was -4, this point is closed, so I do want a line under there. So it's possible to mix your inequality symbols. They don't always have to be matching, okay? We actually have different inequality symbols based on our different kinds of circles. Let's go ahead and let's try our range. Remember, range means y, so now we're looking at all of our y values, okay? All right, destroyed my rectangle there, sorry. There we go. Okay, so all my y values, my lowest point to my highest point, are from here at my highest, here at my lowest. So all through here I have all my y's. My lowest point happens when y is 0. I know that you're looking at this point and you're seeing this 2, but that's an x value, right? It's low, it's on the axis, my y is 0. All the way up to my highest point when the y value is 3. So all my y's are between 0 and 3. Okay, so now this time when I'm looking at points, my lowest point here was when y was 2. See, that's an open circle. When I said y was 0, sorry, not 2. So this gets a less than sign, not or equal to. But then at my highest point when y is 3, it's a closed circle, so we're going to use less than or equal to here. All right, example number 4. This one, we don't have a line, we have a circle. Guys, the same principles apply. And again, to help out my brain, I'm going to go ahead and I'm going to frame this out with my special little rectangle here. This really just helps my brain be able to see the boundaries of the graph that I'm looking at. Okay, it's helping me see the boundaries of the graph that I am looking at. Okay, all right. Now, did you notice that there are no open circles or closed circles? No circles at all, no circles on points means use closed circle. Use less than or equal to. All right, since we don't see an open circle, we're going to assume we're looking at all of these points. We want to be inclusive. We're going to use less than or equal to. All right, so my domain, here we go. Left to right, my points, all within my box. My furthest left point looks like here at 1, 2, 3, 4, 5, -5. all the way to this point over here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. All my x's are between there. Since we just talked about, we're going to use this symbol since we don't have any open circles on the graph. Okay? And now for my range. Here we go. We're going to look at my range next. My range, remember, from the highest to the lowest to the highest points. So here is my box going up to the highest. Okay, this point right here, all the way down to the lowest point, which is all the way down here. All right, so all my y's. Now we're talking about this lowest point, negative 1, 2, 3, 4, 5, 6, 7. No, I think it's just 6. All right, so negative 6 is the lowest. We're going to do this sign for everything. Then my highest point, we got 1, 2, 3, 4, 5, 6, 7, 8, right? Because that's this point here when y is 8. Again, less than or equal to. Okay, example number 5. Here we go, example number 5. We are looking at another kind of strange graph, right? Let's draw a rectangle around it to frame it out so we can really see what we're working with here. Okay. It's not a circle or a line. It's kind of this weird shape. We'll talk more about second semester. So let's look at our domain here first, our x values. Our x values go from here to here. All our x values are contained from the left to right, here to here. Now left, this is when x is negative 1. All the way right, this is when x is positive 2. Okay? Now the furthest left point is this one, and it's an open circle, so we're going to use a less than sign. The furthest right point is here, and we're going to use less than or equal to since it's a closed circle. Now my range on this graph is tricky. Pay attention to the range on this graph. Remember, we're looking at the lowest to the highest points. In this case, I'm not looking at this point for my y value. That's not my lowest or my highest y value. I'm not looking at it. I'm looking at my lowest point to my highest point, right? All the y values in between are my range. My lowest y value happens here when y is negative 3. My highest y value happens here at an endpoint when y is positive 1. Okay? Now here, do you notice that there are no open or closed circles? So we're going to go ahead and use this thing. We're going to assume it's included. But up here when y is 1, it is open, so we'll use a less than sign. That one was kind of tricky. This one is also a little bit trickier, but it's the last one. Here we go. Domain and range. First, I'm going to draw my circle. I'm going to use yellow this time so we can kind of see a little bit better on these graphs. Here is my circle. You notice how I'm going past this dot? Because I have to include everywhere that I have a graph, not just the dots. Everywhere that I have a graph. Here we go. Okay, so my domain are all the way left, all the way right, wherever I have points for my domain. So we've got this point here, which is negative 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way from negative 9 to this point here, which is 1, 2, 3, 4, to positive 4. Both are closed circles, so I get to use less than or equal to for both. Now my range, here we go, lowest to the highest point, right? Lowest to the highest point. We're looking at the bottom to the top for my range here. Well, my lowest point happens down here when y is negative 9. My highest point happens here when y is 3. And since I have only closed circles, I'm going to use less than or equal to for symbols for both. You guys are going to need a lot of practice with domain and range. Okay, so please, if you're not getting it yet, just keep practicing, keep framing your graphs with these boxes. That's going to help you visually to understand your boundaries.